The grandfather paradox is a classic thought experiment in time travel that highlights potential inconsistencies in causality. It goes like this. Suppose you travel back in time and kill your own grandfather before he has children, i.e., before your parent is born. If you succeed, you would never have been born, so how could you have traveled back to commit the act? This creates a logical loop. While time travel remains hypothetical and unproven in physics, several theoretical resolutions have been proposed by physicists, philosophers, and science fiction writers. Here's a breakdown of the main ways the paradox could be solved or avoided. 1. Self-consistency principle, Novikov principle. Named after physicist Igor Novikov, this idea posits that the universe is self-consistent and prevents paradoxes from occurring. Any attempt to change the past would fail or be incorporated into the timeline in a way that maintains consistency. For example, you might try to kill your grandfather but end up failing due to some unforeseen event, e.g. the gun jams, or you accidentally cause a different outcome that still leads to your birth. The past is fixed, and your actions were always part of it. This aligns with some interpretations of general relativity, where closed time-like curves, hypothetical time loops, could exist but wouldn't allow inconsistencies. 2. Many worlds interpretation, parallel universes. Drawing from quantum mechanics, e.g. Hugh Everett's many worlds theory, time travel might branch the timeline into multiple parallel universes. In this scenario, when you go back and kill your grandfather, you create a new timeline where you, from the original timeline, exist, but the you in this new branch never gets born. The original timeline remains unchanged, with your grandfather alive and you returning from the trip. This resolves the paradox by avoiding a single linear timeline. Every possibility spawns its own reality. 3. Timeline. Overwrite or destruction. Some theories suggest that changing the past could overwrite or erase the original timeline entirely, but this often leads to more paradoxes or requires accepting that the traveler becomes orphaned from their original reality. For instance, you kill your grandfather, causing your own non-existence, but the act itself destroys the paradoxical loop, leaving a new, consistent timeline without you in it. However, this is less popular because it doesn't explain how the change initiates if you never existed to make it. 4. Quantum decoherence or information loss. Inspired by black hole physics and quantum information theory, e.g. ideas from Stephen Hawking, paradoxes might be resolved through information loss or decoherence, where contradictory states can't coexist. Essentially, the universe forbids paradoxical events at a fundamental level, perhaps via quantum gravity rules we don't yet understand. Attempts to create a paradox would collapse into non-paradoxical outcomes. 5. No time travel to the past, the simplest solution. Backward time travel might be physically impossible. While Einstein's relativity allows for time dilation, slowing time forward, wormholes or faster-than-light travel could theoretically enable loops, but quantum effects, like Hawking radiation, might close them off before paradoxes arise. This is supported by current physics, as no mechanism for safe, paradox-free backward travel has been demonstrated. These ideas are speculative and debated in fields like theoretical physics and philosophy. For deeper dives, check out books like Black Holes and Time Warps by Kip Thorne, or discussions in quantum gravity research. If time travel ever becomes real, we'd need empirical tests to see which, if any, holds up.